We've been given a function, f of x, and we're told that it is equal to the integral from 2 to the sine of x of square root of 1 plus t squared dt. And we're asked to find the derivative of f of x. Now, it would be very nice if, instead of a sine of x right here, we just had an x. Let's see what that would look like if we had f of x equal to the integral from 2 to just x of square root of 1 plus t squared dt, then this would be very easy to differentiate because we could just use the fundamental theorem of calculus part 1, which tells us that all we need to do is take this x and plug it in for the t right here. And we would find out that this would be equal to the square root of 1 plus x squared. However, we're dealing with sine of x. Now, it's not much harder because we can still do the same thing with sine of x. We just have to remember to use the chain rule. So we're looking at the integral from 2 to the sine of x of square root of 1 plus t squared dt. And this is our f of x. So to differentiate, I can just put this sine of x in for the t, and then I have to remember to use the chain rule and multiply by the derivative of the sine of x. So I know that f prime of x is going to be equal to the square root of 1 plus, just to make this clear, I'll put down sine of x in a different color. Put it down in blue. 1 plus sine of x. And then don't forget, it's squared, so I'll put a squared sign right there. It's sine squared of x. And then we have to remember to use the chain rule, multiply by the derivative of sine of x, which is going to be cosine of x. And now if we look at our answer choices, they used fractional exponents instead of a square root sign. So we can just get rid of the square root sign and change it to the 1/2 power. Erase it. And that will look like this. And if we switch the order of those two factors, we will see that our answer is choice D.